I'm Dr. Rod Shaw. I'm from Math Plus Academy, and I'm back with another math treat. This is one I learned about on Gordon Hamilton's amazing site, mathpickle.com. He's got some really cool unsolved problems that have been adapted for use in a classroom, and this is one that I thought was cool that I'm going to share with you because it relates to some of the math treats that we've done prior to this one. So here we go. Imagine you have a square grid of dots like this, and you choose to draw a closed path. Here I've drawn a couple in blue where all the line segments are horizontal or vertical, so no diagonal lines when I create this path. And you'll notice that the path covers a bunch of the intersection points, or the dots. This one has 3, 4, 5, 6, 7, 8 dots. And what we're going to do is then take those 8 dots and see if we can use 4 of them to make a square. Now this first one is what a mathematician would call trivial because it already is a square. So if I choose these 4 dots on the corners, then obviously I can connect them and make a square. I think that's pretty clear. Now once we've found one, we should look for others. Can you find another one? And if you a rule here that's important is the squares that we make, they don't have to be with horizontal and vertical sides. They could have tilty or diagonal sort of sides. So if I pick the other 4 points around the edge and connect those, I get another square. So this one at least has 2 squares in it. It may have more. I don't know. That's for you to research and find out. Now, I've drawn another path. And what I'm trying to do with this path is trying to avoid making a square. So the question here is, with this zigzag closed path, are there 4 points that I can pick out that form a square? So as I look at this, I think you can probably see pretty clearly there's one for sure right here. And if I were to connect those 4 dots, I get a square. Okay, are there any others? I don't know. Maybe. We would have to spend some time looking for tilty squares. But let's say I want to make this a little harder and eliminate the possibility of finding that square. So I'm going to make a small change. Okay, I've made a change to the shape. I took these 2 segments out and replaced them with these 2. That takes this dot out of the picture, and so I can't make that square anymore. Is there another square that you can find? Do you see it? I see one. I see one here. But if I connect those up, I will get another square. I think you can see that. Okay, so I'm finding it a little difficult to avoid squares. Now I look at this, and I look for some other squares. Maybe there's another one. I stared at this for a while, had a hard time, but I think I finally found another square. If you take this dot and this dot, that's over 2 and up 1. I'll go over 1 and down 2, that's that one. And then down 1 and over 2, that's this one again. And we connect these up. I believe we can convince ourselves that that is also a square. So this one has at least 2. That one had 2. So hopefully you're starting to wonder, like, can I even make one of these that doesn't have a square inside of it, or even 2? So my challenge for you this week is try and make some of these paths and make it such that there are no squares, if that's possible. Or if you have to have at least one, can you make one that just has 1 square and no others? And remember, when you do this, you have to be really careful to look and search. There's probably even another square in here that I totally missed. Maybe you see it and I don't. So as always, I hope you play with this. Just explore, see what you can discover, and then just have fun playing with math.